Welcome to this session. We're doing limits. Okay, so we're going to tackle limits. So these are the questions which were asked in Math 1120, that is 2023 exam for last year. The first question was, in each case below, evaluate the limit if it exists. Limit, so that should be a superscript, a subscript rather, x as it approaches 4. Then this is the fraction divided by that, and also this limit, that should also be a subscript as x approaches 3, and this divided by that. Okay, even before we can answer these questions, let's try to understand something on limits. Okay, let's see what to understand on limits even before we can tackle these questions. Okay, so when you're looking at limits, there are certain things you need to understand. A limit will always be given in a form, let's say limit maybe as x approaches b. Then you have maybe a situation of a quadratic like that. So what it simply means is that once you substitute this subscript, which is, let's say, x is equal to b, I'm not talking about this b, let me use a different letter maybe. Okay, here let me use a letter maybe k. So what it simply means that once you substitute this subscript in this function you've been given, that's when you can be able to evaluate the limit. Okay, but there are certain things you need to understand even before you can evaluate that kind of limit. Let's look at a certain scenario whereby you've been given, let's say, limit, evaluate limit maybe as x is approaching maybe 3. Then you've been given a function, it be x squared plus 4x plus 1. This is a quadratic. Limit as x approaches 3. So for this certain equation, or limit rather, you can just substitute where there's x. This is a direct one. Where there's x, you can substitute 3 squared plus 4. Where there's x, you can substitute 3 plus 1, and that will give you, that is 3 squared, that is 9. 9 plus 4 times 3, that is 12. 12 plus 1, and the answer you are going to get will be equal to, that is 9 plus 1, that is 10. 10 plus 12, that should be 22. You have evaluated the limit. Okay, so this is a straightforward kind of a question. But let's say you've been given an instance whereby you've been told limit, let's say as x is approaching c, then you've been asked to evaluate a function in a form of, let's say, x squared plus 2x plus 1. Then at the bottom you have, let's say, x plus 1. You can't evaluate this function directly. Okay, and to make it interesting, let me put a value there. Let me say -1. So this kind of a function can't be evaluated directly. Okay, this kind of a function can't be evaluated directly, because if you substitute where there's x in this function, there you substitute -1, even there -1, there -1, you see at the bottom it is going to give you something indefinite, okay, something undefined. So if you substitute this -1 at the bottom to give you something like x squared plus 2x plus 1 over 0, and we know that when a fraction is over 0, it is undefined, so this kind of situation can't work. So what do? The first thing you need to do here, you need to factorize this. When you factorize this, you'll find first the product, sum, and the factor. So the product there, it will be just positive 1. The sum is just 2. The factors are now 1, 1. Those are the factors, 1, 1. Then you do the factorization, so it will be x squared plus x plus 1, then over x plus 1. Then at this point you can factorize this in pairs. You can say x, then x plus 1, then again plus 1, then x plus 1. Then you say over x plus 1. Then this x plus 1 can cancel with 1x plus 1, because what you have at the numerator, it's simply, if you group this, it will be x plus 1 plus x plus 1 over x plus 1. So definitely this can cancel with that. Then what you're going to remain with is just x plus 1. Then you can bring down this limit and you can substitute now -1. Then you get the answer there. If you substitute -1, that will be just a 0. You've evaluated the limit, but going directly, you won't find the answer. Let's say you've been given an instance whereby, let's say limit, I can give an example. Let's say x as it approaches, let me just use a letter b. Then you have a certain function like this, maybe 3b plus, let's say 7 over, let me use a certain expression. Let's say you have maybe 4 plus, then square root of maybe b plus, maybe let me say not even b plus, let me say square root of which number can I use? Maybe 6 minus b. Okay, then you've been told to evaluate this kind of a limit. So at this point, you can do also directly, okay? You can't evaluate directly by substituting b and b. Let's take it a situation whereby b is equal to 6. Okay, b is equal to 6, so that is 0. Okay, which value can make, let me say, because this will be 6 minus b, that is 6 minus 6, that is 0. Okay, let me say I don't have anything here. The function is just like this, square root of 6 minus b. Okay, let's take this kind of a situation. We have been given this kind of equation. So if you substitute 6 directly there on b, you get 6 minus 6, that is 0. Square root of 0 is just 0. So this function will be undefined also. So what can you do? At this point, you need first to find the conjugate of this, the conjugate of the denominator, okay? So you need first to evaluate the conjugate of this denominator you multiply it on top and at the bottom. So you multiply by a conjugate there, even at the bottom by a conjugate. Then once you evaluate that, something will cancel at a certain point, or even if they don't cancel, once you've evaluated by multiplying by a conjugate, then you substitute x is equal to x as it approaches 6, you'll be able to find the value, unlike this kind of a situation. Okay, so let's now tackle these questions with that understanding. Okay, let's begin with the first question, which was evaluate limit as x. Okay, limit as x approaches 4. Then you have x squared minus 5x plus 4, then over x cubed, it was x cubed rather, then minus 64. Let me just check if I've written the right thing. Okay, that is the question. So how can you evaluate this kind of a limit? So as we said, we need first to do some factorization on the numerator and also on the denominator, so to see if we can evaluate it. Okay, so I'm going to say limit as x approaches 4. We can factorize this, the top part there. The product is just 4. The sum is just -5, so the factors will be -1 and -4. So if we do the substitution there to replace b, it will be x squared. Then we are going to have minus x minus 4x plus 4 over, at the bottom, the simplest way to evaluate this, you just say the cube root of 64, that is just a 4. So you just say x, you take the sign which is there, which is minus 4. Then you change this, you write now the quadratic, which when you multiply by x minus 4 will take you back to this cubic function. So it is simply x squared. So you just need to take the same negative there, negative 4x. When you say negative 4x, then here you now say negative 4 squared. That will give you 16. So it should be 16 there. In fact, even there you maintain this side for the quadratic. You always need to maintain the sign. There should be plus there, even plus, because once you multiply with this minus, it will take you back to this x squared minus. So that is just the simplest way you can factorize that. Okay, then what I can do on the top part, on the numerator, I can say limit as x is approaching 4. I can factorize this in pairs, so it will be x open brackets x minus 1, then minus 4 x minus 1. Okay, so that is on the numerator part. I've factorized that. Then excuse me, now on the denominator, I'm going to have x minus 4 in brackets like that, so x squared plus 4x plus 16. Okay, so this is what I have at this point. So I can say limit as x is approaching 4. I can now factorize, I can group that in pairs, so it will be x minus 1, x minus 4 over x minus 4 then what I have there is x squared plus 4x plus 16. Then at this point, you can see that x minus 4 can cancel out with x minus 4 on the numerator. This x minus 4 on the denominator can cancel out with the 1 on the numerator. So what we have now at this point is limit as x is approaching 4. So I'll remain with x minus 1 over, at the bottom I just have x squared plus 4x plus 16. Then I can get rid of this. Okay, at this point now I can substitute. Once you do the substitution, you forget this limit now. Okay, you get rid of the limit, so it will be is equal to 4 minus 1 over, that is 4 squared plus 4, where there is, okay, let me write this, where there is x I substitute 4, then plus 16. So this will be equal to 4 minus 1, that is just 4 minus 1, that is a 3, over, then 4 squared, this is a 16, 4 times 4, that is again plus 16, then plus 16 also that one. So we're going to have 3 over 16 plus 16 plus 16, that should give a 48. Okay, so if you try to simplify this further, if you try to simplify 3 over 48, you're going to get 1 over 3 there, it's just 1, 3 into 48, that should give 16. Okay, 3 over 48, that should give a 16. So that is our answer, 1 over 16. So after you evaluate, that is the answer we are getting. Alright, so let's now do the next part. Let's do the next question. So the next question is evaluate limit as it approaches 3, as x approaches 3, then 3x plus 9, then divide by 3 plus square root of 6 minus x. Okay, so this is the question. Let me write it here. So limit as x approaches, that is negative 3. Okay, as x approaches positive 3, then we have 3x plus 9 over negative 3, then we had plus square root of 6 minus x. So as I mentioned earlier, in this instance, if we try to substitute 3 there, where there is x on the denominator, even there on the numerator, we discover that we're going to have 6 minus 3, that is just 3. In fact, we won't even be able to evaluate this if we just substitute directly. So we need to do something here. So basically what you need to do is to multiply first the first part by the conjugate. Okay, you multiply the numerator and the denominator by the conjugate of the denominator. So the conjugate is, so negative 3, it will be negative 3. We just interchange the sign. Where there is plus, you put a minus, then square root of 6 minus x. Even on the denominator, you say negative 3 minus square root of 6 minus x. So after you do that, that's when you can now continue to say limit as x approaches 3. So I'll have 3x plus 9 in brackets. It is being multiplied by negative 3 minus square root of 6 minus x over. So the simplest way to evaluate this is just difference of two squares. So you just take the one which has a minus there. So it will be negative 3 squared like that minus open brackets. Then you say square root of 6 minus x also squared. So you just take this, then you change it into a difference of two square. Okay, so basically that's what you need to do there. Let me just get rid of the top part. Okay, so what we are going to have basically is limit as x approaches 3. As x approaches 3, so we're going to have 3x plus 9 in parentheses like that. Then we have negative 3 minus root of 6 minus x. So let me just get rid of the numerator. I've written it already. Then I'll say over, on the denominator I have negative 3 squared. Negative 3 squared, that is just a 9. Then minus this 2, this square I mean, will cancel with the square root. So what I remain within the brackets is 6 minus x. There. Okay. At this point now, what I can do, I can say limit as x approaches 3, I'll have 3x plus 9, then negative 3 minus square root of 6 minus x over. This can be evaluated to 9. This negative will multiply 6 in the parentheses, so it will be 9 minus 6. 9 minus 6, then negative multiplied by negative there, it will be positive, so it will be plus x. And 9 minus 6 is just a 3, so it will be 3 plus x. Okay, so on the denominator I'm going to have 3 plus x, which is just x plus 3. It is the same as x plus 3. Okay, then at this point now I can do something on the numerator. You see, we have 3x plus 9 there, so I can factorize that 3 so that I remain with x plus 3 in the bracket. Okay, so basically what I want to do here is I have 3x plus 9 rather, so I can factorize 3, then I remain with x plus 3 in parentheses. Okay, so basically that is what I'm going to substitute there. So I'm going to have 3 open brackets, then x plus 3. So that is what I have, and this x plus 3 can cancel now with that x plus 3. Okay, to make things easy. So what I'm going to remain with is what I'm going to write here. So what I remain with is limit as x approaches 3. So I have 3 there, 3 remained, now multiplied by negative 3 minus square root of 6 minus x. So that is just what I'm remaining with. So everything can now be erased. Okay, then at this point it's very simple now. I can even do the substitution. So I'll just say equal to 3 open brackets negative 3 minus square root of 6, where there is x, I'll substitute now 3. Okay, so I'm going to remain with 3 open bracket negative 3 minus 6 minus 3, so I'm going to remain with 3 in brackets. Okay, 6 minus 3, so I'm going to remain with 3. Actually the limit was a negative. Let me just try to check in the actual exam paper. Okay, so the limit was negative, not a positive. So the limit there was a negative. Limit was a negative. So if I do the substitution there, I need to say negative there, negative 3. So if I do the substitution on x, I put negative 3, so it will be negative multiplied by negative, it will be positive now. So I should have positive 3 there. So 6 plus 3, that is just a 9. Okay, so the limit was negative. Okay, so this is equal to 3 open bracket negative 3 minus square root of 9, that is just a 3. So we're going to have 3 open brackets negative 3 minus 3, that is just a negative 6. Then 3 times negative 6, that is negative 18. And that will be the final answer. So this is how you can evaluate these questions which were asked last year for Math 2023 exam. So if you found this helpful, don't forget to like, share, comment, and also subscribe. Thank you for watching. Have a great day.